All right, so today we're going to be talking about what solutions to a system of equations is. Now, first we have to talk about that a system of equations is two linear equations, sometimes more when you get to algebra 2, with the same variables graphed on the same coordinate plane. A solution to a system of equations is the point where two or more lines intersect. Now that two or more, again, is going to happen when you're in algebra 2. So if you want to put or more, you can. But again, that's only going to be for algebra 2. In algebra 1, we only do one thing. All right. On the next set of examples and problems, what we're going to be doing is we're going to be using the information given and either circle or highlight the solution, then write the solution as an ordered pair. I'm going to be using color so that it kind of sticks out. If you want to do the same, you're more than welcome to do so. All right, so we've got two lines. Now remember, a solution is where the two lines intersect. So there's one intersection point here, and that point is at coordinate pair 0, 7. So your solution, which by the way, there's only one solution for this, is 0, 7. The next one, no matter how long this graph goes, these lines will never intersect. They are parallel lines, and you can even check that by the slope. Because the top line, that's a -3/4 for the slope. Bottom line, same thing, -3/4. Because they have the same line, they are parallel. The lines will never intersect, they are parallel. I want you to write that. Now, typically for an answer, you're going to write no solution. Sometimes you're going to be asked, is it a one solution, no solution, or infinitely many? Those are the three types of answers you can get when you're doing a system of equations. All right, now that we go to the next part, these are going to be a little bit different. These are tables here. So what I like to do is I look at it one column at a time, and I look at my second and third column, because right here, this is where my output is. It's where my y values are. And they match over here when they're both 5. And that's when my x is equal to 3. That means our coordinate pair or our solution is going to be 3, 5. And that's because it's the same point. Right here, it's 3, 5 on y equals 2x minus 1. And then on y equals x plus 2, it's also 3, 5 with your x and your y, writing it as a coordinate pair. Now, this next one, same thing, and you might already be able to see it. And you see it when both your y values are -1. Yeah, when they're the same. Which means, right here, in order for me to write this as a coordinate pair, I'm going to use my x value and my y value. And it doesn't matter which y value I use from which column, because they're both the same y values. That's what you want. You want the output to be the same. So your solution for this would be -2, -1. Number 5 and 6 are just like 3 and 4. So let's do them. All right. Well, I don't see anything that matches, no matter which column I look at for my y's. But I want you to look at your equation part right here and look at the slope in particular. The slope for this first line is 5. the slope for the second line is also 5. And because they have the same slope, the lines are also parallel, which means they will never intersect. And there will never intersect. There's no intersection, there's no solution. So remember, same slope means parallel lines. I want you to write that in if you were like, ooh, I struggled with this last chapter. So now number 6, let's do it. You'll notice that it's actually right here at -2, 2. Because both of our outputs are 2 when our input is a -2. Your input and your output have to match. All right, last ones we're going to have to graph. I love to use colors when I'm doing a system of equations because I'm literally graphing 2 equations. And when you'd be in your calculator, you would label them as y1 and y2. And I've color coordinated them as y1 is orange and y2 is green. And now we're going to graph both of our lines. Remember that the y-intercept of our first line is a -1, which means I'm going to start at 0, -1, our y-intercept. Our slope is 3/2. Since it's positive, we're going to go up, and we always go to the right. Which means you're going to go up 3, to the right 2, all right? And then now that you've got 2 points, you're going to draw your line. We're going to do the same thing with y2. Our y-intercept for this is 4, which means we plot our y-intercept at 0, 4. Our slope for this is not -x. -x is not a number. Our slope for this is -1, meaning we're going to go down 1 and always to the right. In this case, it'll be a 1. I'll go down 1. And I'm so close to the solution here, I kind of going to make another point. And notice what happens. It overlaps with that orange. They're on the same exact spot. When those 2 lines intersect is that solution. So our line's solution, our system solution is 2, 2. All right, let's graph 8. But even before you look at it, first line, our y-intercept is 3, and our slope is 4. Same thing for our second line. Now, what that means is, yes, it's got the same slope, and you're automatically thinking, oh, it's got to be parallel. But it's also got the same y-intercept, meaning they're the exact same line. So we're going to start at 3, and we can't go up 4 and to the right 1. So we're going to go turn our paper around from our 3 and go up 4 to the right 1 there. And I can't do it on my iPad, but you can do it on your paper. So turn your paper upside down since we don't have enough room to go up 4. So turn your paper upside down. And then you're going to go from the y-intercept, you're going to go up 4 and always to the right. And in this case, we're going to go right 1. Now, notice if I graph that second line, isn't it going to be the exact same line? So because it's going to be the exact same line, it's actually going to be infinite solution. Because it's going to touch the other line an infinite number of times. You are you, no matter how many times I ask you. You are always going to be you. An infinite solution is going to be when it's the same exact line. It's got the same slope and the same y-intercept.